Hello friends, welcome to Sidza.com. Now in this video we will learn about the mole concept. 1 mole of a substance is the amount of a substance that contains as many particles as we find in 12 grams of the carbon 12 isotope. And how many particles are present in 12 grams of the carbon 12 isotope? Experimentally, it is found that the number of particles present in the 12 grams of the carbon 12 isotope, so that means if you take 12 grams of the C12 isotope, it contains the number of particles equal to 6.022 times 10 power 23. So this number of particles are actually present in 12 grams of the carbon 12 isotope, right? And this number is called as Avogadro number. So 6.022 into 10 power 23, this is the number of particles actually present in 1 mole, right? In 1 mole. Okay, so 1 mole is basically 6.022 into 10 power 23 particles. This number of particles is called as a 1 mole, right? And in 12 grams of carbon 12 isotope, we find 6.022 into 10 power 23 particles. Therefore, 1 mole of a substance is the amount of a substance that contains exactly the same number of particles as we find in 12 grams of carbon 12. We know carbon, its atomic number here is 6 and here the atomic mass is 12. So 12 AMU, 12 atomic mass unit, right? AMU, this is the atomic mass of a 1 carbon. When you express the atomic mass of the carbon in grams, that means 12 grams of carbon, it contains how many particles? It contains 6.022 times 10 power 23. So that means 1 mole of a carbon is actually 12 grams of the carbon, right? So 1 mole of a carbon is 12 grams of the carbon. So therefore, when we express the atomic mass of an element in grams, that contains 1 mole of that substance. It contains 6.022 into 10 power 23 particles. So that's why we say the molar mass of a carbon is 12, right? So this is the molar mass of a carbon, right? Molar mass is the weight of the substance that contains 1 mole of that substance, that contains 6.022 into 10 power 23 particles. So molar mass of an element contains the Avogadro number of the particles. So similarly, we can talk about sodium. 1 mole of the sodium is how much? It is 23 grams of the sodium. For sodium, its atomic number is 23, atomic mass is 23. So therefore, when I express the atomic mass of the carbon of the sodium here in grams, which means 23 grams of the sodium, right, contains how much? It contains the Avogadro number, which is 6.022 times 10 power 23 sodium atoms, right? Which means 23 grams of the sodium will be equal to 1 mole of the sodium. Hence, atomic mass of an element expressed in grams is the molar mass of the element. Suppose we have here the sulfur, and sulfur we know atomic number is 16, atomic mass is 32. So when you express the atomic mass of sulfur in grams, that is the molar mass of the sulfur, right? So that means 32 grams of the sulfur will be equal to 1 mole of the sulfur, means it contains 6.022 times 10 power 23 sulfur atoms. For the iron, atomic number is 26, atomic mass is 56. 56 grams of iron equals 1 mole of iron, right? Which means it contains 6.022 times 10 power 23 iron atoms. For the carbon here, this is the carbon, atomic number 6, atomic mass is 12. So 12 grams of the carbon will be equal to 1 mole of the carbon, which is the Avogadro number. For copper, we know the atomic number for the copper is 29 and atomic mass is 63.5. So therefore 63.5 grams of the carbon will be equal to 1 mole of the copper, which is the Avogadro number, which is equal to 6.022 times 10 power 23 copper atoms, right? So what we have learned so far, that atomic mass of an element expressed in the grams is the molar mass, contains 1 mole of that element. So like here we learned that 12 grams of a carbon equals the 1 mole of a carbon. You know, if you need 2 moles of the carbon, so it will be 2 moles of the carbon will be equal to 12 times 2 grams of carbon, which is equal to 24 grams of the carbon. So therefore we can relate here the number of the moles of the substance with the weight of the substance and the atomic weight of the substance. It means number of the moles of a substance will be the weight of the substance expressed in the grams divided by the atomic weight. Means if you want to find how many moles are present in 24 grams, you know, let's cross check it again. In 24 grams of the carbon, how many moles are actually present there? So we got here the weight is 24. So you want to calculate the n, the number of moles, right? In 24 grams of carbon, so n, the number of moles, will be equal to weight of the substance, which here in this case is 24 grams, divided by the atomic mass of the carbon, that is 12, which is 2. So hence in 24 grams of the carbon you got 2 moles of the carbon. Hence we can write down the number of the moles of the substance. The number of moles of any element will be equal to the weight of the element divided by the atomic weight of the element. For example, if you want to calculate the number of the moles, right, of carbon in 18 grams of carbon, and so therefore n will be equal to 18, that is the weight of the element, divided by the atomic weight of an element. What is that? It is 12. 3 by 2, it is 1.5 moles. Similarly, for the 64 grams of sulfur, contains how many moles of sulfur? So 64 grams, n will be weight of the substance divided by the atomic weight. So here the weight is 64 and the atomic weight of the sulfur is 32, so it is 2 moles. That means in 64 grams of the sulfur it contains 2 moles. So 64 grams of sulfur means 2 moles of the sulfur. Now let's calculate here the weight of the 0.35 moles of zinc, right? So zinc, we know its atomic number is 30 and the atomic mass is 65.7, right? Now we need to find the weight of the substance for 0.35 moles of the zinc, right? We know the N, the number of moles, is equal to weight of the substance in grams, right, divided by the atomic weight, right, of the element. And we got here N here is 0.356. That will be equal to the weight of the substance in grams divided by the atomic weight of the zinc is 65.7. Hence the weight of the zinc will be equal to 0.356 times 65.7. So when I solve it, it is 23.389 grams of the zinc. It means that 0.35 moles of the zinc has a weight of 23.38 grams. Now let's calculate the number of the atoms present in 0.551 grams of the potassium, right? Okay, so the potassium here with the atomic number is 19 and the atomic mass is 39. For the potassium, the atomic mass is 39 and the atomic number is 19. The number of moles we know. Let's first calculate the number of moles, and from the number of moles we can calculate the number of particles. So first let's calculate the number of moles. So number of moles present in 0.551 grams. So the weight here is, this is the weight by atomic weight of the element. So the weight here is 0.551 grams of potassium and the atomic weight of the potassium is 39. And when we solve it, 0.551 by 39, it is 0.0141 moles, right, of the potassium. Now 1 mole of a substance is Avogadro's number, that is 6.022 times 10 power 23. This is the number of particles present in the 1 mole. So in 0.0141 moles, how many particles will be present? How many atoms of sodium will be there? So the number of atoms will be equal to the number of moles into the Avogadro number, right? N is the number of moles into Avogadro number. Hence, number of moles we got here is 0.0141 and the Avogadro number is 6.022 times 10 power 23. So when I solve it, it is 0.085 times 10 to the power 23, or you can say it is 8.5 times 10 to the power 21 number of atoms. Now let's take another question. Here we want to calculate. Now here in this question we have to calculate the number of the grams of the lead in 12.4 moles of lead. So we have to actually find the weight of the lead for 12.4 moles of the lead. Lead with the atomic number 82 and the atomic mass is 207, right? And for 12.4 moles of the lead we have to find the weight. We know N is the weight of the substance in grams divided by the atomic weight of the substance. So number of moles we know, we have to only find the weight. We have to find this weight, okay? And we know atomic mass of the element we know. So therefore the weight of the lead will be equal to N, the number of moles, times the atomic weight. So the number of moles is 12.4 times the atomic weight of the lead is 207. So this is equal to 2566.8 grams. That means 12.4 moles of the lead has a weight of 2566.8 grams. Hope you got the concept. Thanks for watching the video. Bye for now.